are so many quantum computers in the world, and this is the one of the example for this. For example, D-Wave company is producing a quantum computer for optimization problems, for machine learning problems, and you can use it, and it is the performance of this problem is very high. Then you don't need a supercomputer to find new solutions for your problems, and quantum computer is a nice solution to obtain high performance solutions. And also Google is producing quantum computers, and it can be used in several problems and optimization, machine learning, and some cryptographic problems to solve, to analyze the algorithms. And when we check the IBM roadmap for the post-quantum issues or quantum computing, we are now in the 2024. IBM will produce more than 1,000 qubits. And also they are producing a new software, a new operating system, and new softwares to handle the issues and to obtain a large-scale computer, quantum computer, and it can be used in several problems. Up to now, we can use the IBM quantum computer for machine learning, for the natural sciences, and the optimization problems. At the end of 2026, we hope that we have so many quantum computers with high capabilities. And this means that you can use quantum computers to solve the different problems, from optimization to cryptanalysis and for the financial problems. And all over the world, there are so many efforts to build a big quantum computers by using the different technologies. There are research centers, companies, universities, and so many researchers are interested in to build a quantum computer with high qubits. And qubit is gives the size of your quantum computer or the performance possibilities for the quantum computers. And you can think about how many qubits do we need to break the public key algorithms. And when you think about the RSA, which is used in the SSL certificates, then you can see you need to double the bits to obtain the number of the qubits. And if you are using 2048-bit RSA, then you need at least or almost 4,096 qubits to break the RSA. And you will need the time 9 to 10 seconds. And you will need the 9 to 10 seconds. And also you can break the elliptic curves by considering the Shor algorithm, and you can use the quantum computers. You will need less qubits with the same security size when compared with the RSA. And you will almost receive the same seconds to break elliptic curves. And there are so many studies. Since we don't have that large of quantum computers, we always guess by using the Shor algorithm. And there are so many studies on these issues. And our aim is to break RSA and elliptic curve or public key schemes in hours or in seconds or in minutes in a reasonable time. And you can see that there are the number of the qubits will be more than million. If you build a quantum computer which has more than million qubits, then you can break RSA within hours. And it is very important thing. Why? When you think about the IBM roadmap, we can reach these numbers according to the guess, we have so many guesses for this, within 6 years. So quantum computers will be very big problem for the public key schemes. In order to achieve, in order to understand this issue, we need to see that how many qubits we will need and how many hours you can break the RSA scheme or elliptic curve schemes or Diffie-Hellman key exchange schemes. Those are in the same issue. And there are so many quantum algorithms, and quantum algorithms are not responsible to break the schemes only, and you can use these quantum algorithms to solve so many different problems. For instance, algebraic problems, number theoretical problems, machine learning, optimization problems, natural programming issues, and the other things, or deep learning, in order to increase your performance for the educational side and the supervisional side. You can use quantum computers, and there are so many algorithms for the quantum computers. Since the idea from the bit to qubit is changing, you have to change your algorithm, and the success ratio of your algorithm is also changing. And you need to use those algorithms for the quantum computers. And when we have a quantum computer, we will see that RSA elliptic curve schemes, Diffie-Hellman will be insecure in the quantum computing age. However, the symmetric key schemes will be secure if you increase the key sizes. If you don't increase the key sizes, their security level will be half. So it will be a big problem for the old cryptographic algorithms. For instance, advanced encryption standard or the hash functions. You need to increase the output size or the key size. Then you will obtain a secure scheme. And if you increase the key sizes or the output sizes, this means that the performance will be low. And we have a trade-off to obtain the security in different ways. And we know that we are using cryptographic algorithms in our daily life, in our SIM cards, mobile phones, online banking issues, SSL certificates, or in any other certificates, SSH, Kerberos, IPsec, and in everywhere we are using the public key schemes, key exchange schemes, digital signatures, and public key encryption schemes, key encapsulation mechanisms, and those should be in quantum safe. And we need to compute the security in the quantum era. And we have X, we have Y, and we have Z. In X means that how long do you need your keys to remain secure? Y means that how long will it take to deploy a set of tools that are quantum safe? Z is the how long will it be before a quantum computer or any other method you can think about breaks the currently deployed public key tools. According to the theorem of the Mosca, if X plus Y is larger than Z, then we have a very big problem. And we are now at the end of the Z in general. So we have to make some decisions, and we have to find solutions. These solutions can be hybrid mode or just post-quantum mode. And how we can build a new scheme for the post-quantum world, we need to check the hard problems, computational hard problems, or cryptographically hard problems. We know that we have P class, NP class, and NP class is in NP complete or NP hard. We always look for the NP class. However, we know that according to the Shor algorithm, there are some solutions for the NP problems. For instance, integer factorization or discrete logarithm problems. We have polynomial time algorithms in quantum computers. So they are in P class in the quantum world. This means that we have to find any hard problems in NP class, which is still in NP class in quantum world. So we need to look this NP problems. And is there any that kind of problems? Yes, we have so many things for this: code-based schemes, hash-based, multivariate quadratic, lattice-based, curve-based, symmetric-based, and the others. And each of them has some advantages and disadvantages. Some of them is very efficient, but they have very large key sizes when we compare with the RSA or the Feynman or elliptic curve schemes. And some of them has small sizes, however, they are not very efficient. So we have some problems for this, and also we have some security problems. We don't have any proof that those schemes will remain secure in quantum world. So we have to be very careful while choosing the problem and the other things, hard problems, and construct the scheme. What can we do to build a quantum resistant scheme? First of all, you have to choose the quantum resistant problem. Then you have to decide which primitive you will continue: signature scheme or key encapsulation mechanism or encryption scheme. Then you have to make the security analysis for this primitive. You will need some parameter sets to obtain to show that your scheme can be applicable, and you can prove your security by considering the different security levels. And then you have to optimize your performance by considering the parameter sets and for any level, for any security level. Let's take some hard problems from the code-based, lattice-based, and the other problems. You can think about the code-based schemes as a matrix vector product. However, these matrices and vectors have some special elements and has special architectures. In this architecture, you have to think about how many ones in your vectors or matrices, and everything is chosen in the binary field in general, and you need to decide the Hamming weight, which is the number of the non-zero elements we are looking for, and everything should satisfy the number of the non-zero elements. If the number of the non-zero elements is very high, you will have some problems, and it can be solved. In order to understand the hardness of the problem, we need to decide the limits for the number of the zeros, and those are related with the size of the matrices and the other things. And the name of the problem is the syndrome decoding problem. And also we have multivariate quadratic polynomial based schemes. It is much more easier than the previous one. Why? First of all, we have to find a nonlinear, a polynomial. The degree of this nonlinear polynomial is only 2. So we call this one quadratic polynomial. And we want to find a solution in a finite field. The size of the finite field is not very large. For instance, you can choose it a binary field, or you can choose it F31, which is not so large, and it is small, but it is a Mersenne prime, for instance. And you have this kind of sets, this kind of quadratic polynomial set, then you are trying to find the solution. And it is not easy to find this one, and you can think about it is the small scale version of the Hallock ciphers. You can write the output of the Hallock ciphers in a polynomial, and you cannot solve this one. Why? You will have a nonlinear equations, and these nonlinear, the degree of those nonlinear equations is very large. So it is not easy to find a solution for them. And when we come to the lattice space schemes is very popular. It has so many advantages on the previous schemes, which we mentioned, multivariate and full code base. They are very efficient in the key sizes and also performance when compared with the traditional schemes. Those have reasonable limits for this. And here we have the same thing. Like in code-based schemes, and you can think about lattice-based schemes is the analog of the code-based schemes. Here we are choosing the matrices from our finite field, and the size of this finite field is large when compared with the code-based schemes, and it is almost at least 10 bits, for instance. Then you are choosing a uniformly random matrix from those finite fields, and you are making the matrix vector product. The properties of these integer vector, and you need to compute the number of the non-zero elements as well. And we are talking about the norm. The norm of this vector should not exceed a limit. If it exceeds, then you cannot find a solution. So we call this one short integer solution. And in lattice space, we have two main problems. One of them is the shortest vector problem, why we are looking for the norm, and the other one is the closest vector problem. We have two vectors, and we are measuring the distance between those vectors. Then you can continue to find the solution. Another interesting problem for the lattice-based schemes, when you multiply two vectors, you obtain a result in modular arithmetic. And if you know the solution, and if you know the one vector, then it is not possible to find if the other conditions are satisfied, the norm and the limits. It is hard to find the other multiplicand. So it is also called NTRU problem. In the naive schemes of the lattice space, new hard problems have been defined, and the most important one is the learning with errors problem. In learning with errors problem, we have two vectors, we make the inner product, and we add a noise. This means that when you think about in a geometric way, you have 2 points, and you are adding noise. And by adding those noise, the result will not be in this lattice, and will not be a point in this lattice. So you have to check what is the closest point to obtain the result. And we call this one, it's a learning with errors problem. We have so many types for the learning with errors problem. For instance, ring learning with errors for the polynomial side. We know that there is an isomorphism between the vector space and the finite fields. Then you can move the elements between two of them. So what should we do in the quantum age? We always think in a different way. And we know that nobody can guarantee that these hard problems will be secure in the future. Everybody is working on this issue, and if you find a new method for this, then you can break the schemes. And what are the challenges in the post-quantum world? First of all, we need an efficient scheme. When we compare with RSA, elliptic curve, and Diffie-Hellman, those are the traditional public key schemes, but we have to provide as efficient as this kind of schemes. And we have to find a secure scheme, and everybody should believe that this is secure, and they should be used. And usability of these post-quantum schemes will be everywhere. In our smart cards, we can use this one in our smart cards, in our mobile phones, in our computers, in any hardwares, FPGA or the other things. So usability of these schemes should be at least traditional public key schemes. And let's start with the standardization issues. Is the National Institute of Science and Technology of USA. They started so many standardization issues for the cryptographic schemes, and the well-knowns are the block ciphers and the hash functions and the lightweight schemes. Lightweight is a kind of block cipher in their code. Advanced encryption standardization issue was completed in 2001, and there were 15 candidates from all over the world. They have 2 rounds, and at the end there were 5 finalists, and Rheindoll algorithm from Belgium and Austria was selected as a standard, and we are using the advanced encryption standard in our daily life. In our to encrypt any data, we are using the advanced encryption standard in different modes. We are the hash function competition. It was completed in 2012. SHA-3, which is known as a Ketchak algorithm, was selected for the SHA-3, and there were 64 submissions from all over the world. And at the end, we have 5 finalists, we have 2 rounds. We are now a standard for the Ketchak algorithm for SHA-3, but we are not using in everywhere, since we don't have so many big problems with the SHA-2. We are also using SHA-2 now. And another standardization issue, lightweight algorithm, ASCON was selected for the standard for the lightweight algorithms. You can use this algorithm, authenticated encryption algorithm, instead of IS in your devices. And there were 57 submissions, and we are looking for the standardization, the last minutes of the standardization. Then we will see that it was selected, but we have some problems to complete the standardization issues and the usability of the algorithm. If the industry does not want to use those algorithms, then your standardization does not mean anything. When you think about the block ciphers, hash functions, and lightweight issues, those are all in the symmetric class. And NIST started for the first time for the public key schemes competition or the standardization issues for the post-quantum algorithms. Post-quantum is relatively new when we think about the public key schemes. However, we know that code-based schemes are as old as RSA, and they are proposed almost the same years. However, according to the key sizes, when you compare with the RSA, those are not applicable, those are not usable in 1970s, and they have so many problems. So code-based schemes don't have applications in the real world. But NIST started these standardization issues by sending call for papers in 2016, and they put a deadline for the submissions in 2017. They started to evaluate the algorithms in 2018, and in 2019, 20, and 22, they explained, they announced their reports and their selection ideas, which algorithm is better and which algorithm can be used in different ways, then you can use those algorithms. And what do they want? Their aim is to obtain digital signature schemes, which is secure, and public key encryption or key encapsulation mechanisms. The security is related with the chosen ciphertext attacks up to some limits, and everything should be open. And everyone can access the algorithms, can use those algorithms to cryptanalyze the issues. And at the end, we won't have only one winner, like in RSA, like in Advanced Encryption Standard or SHA-3. And we know that there were only one winner in the previous computation standardization issues. Advanced Encryption Standard is the only one winner, and SHA-3 Ketchak algorithm is the only one winner. But here, post-quantum, since we don't know the future, we cannot guess the future. We don't have to put all eggs in one basket. The hard problems should be selected, and according to the hard problems, lattice-based schemes, code-based schemes, symmetric-based schemes, and the other families should be used separately. If one of them has a problem in the security, then you can use the others. You don't have to wait the new standardization efforts. And according to the evaluation, first, the scheme should be secure by considering the symmetric key sizes level. Advanced Encryption Standard or SHA-3 SHA was selected according to the outputs, and exhaustive key search and the collision search was considered. And the performance should be given in different platforms, FPGA, for instance, or hardware, or in software. You have to provide reference implementation and optimized implementation for the software. And you have to put your implementation into some devices, into some processors, different platforms, for instance, ARM Cortex M4, and your algorithm should have different properties. They should satisfy, for instance, for the key exchange schemes, perfect forward secrecy. And they have to be resistant according to the implementation attack. They have to be simple. They have to be flexible. And many other things which we are using in our daily life should be satisfied for this. And we are looking for the algorithm which have so many properties. So it is a kind of strange and challenging issues to cover the all properties. And there were 82 submissions from all over the world, and only 69 of them accepted as a complete and proper application submission. Those are in the lattice-based, code-based, multivariate, symmetric-based, and the other some algebraic tools they are used. For instance, some group-based schemes were submitted for the encryption schemes. According to this table, the number of the lattice-based schemes which are proposed is the highest one. And here is the list of all submissions. There are so many different submissions from here. And at the end of the first round, more than half was eliminated. And again, the number of the lattice-based schemes is the highest number. When we compare with we came here from 69 submissions to 26 submissions, and we have 17 encapsulation mechanism of the encryption scheme and only 9 signature schemes. And the numbers are decreasing in each round. According to the report, according to this collection, NIST announced a report, and they are looking for the security, cost and performance, and the implementation characteristics. Also, theoretical sites. According to the theoretical sites, they are looking for the hard problems. which hard problems is used, and the other things. For the implementation side, they are always looking for the implementable ideas, and those can be used in hardware and the software problems. They are always looking for this one. Since they ask the C codes, they are looking for, can we implement this one, or can we run the algorithm in different problems, such as smart cards and the other things. According to the first round, NIST studied the arguments for the security, and they presented a submission package. Everybody can check and see the problems. And according to the results of the first round, NIST did not care the implementation performance. They are looking for the security options. At first, if your scheme was secure according to the that literature, then your scheme was selected for the second round. And they are always looking for the uniqueness and the elegance of the scheme. And in the second round, at the beginning of the second round, the algorithms and the hard problems, they depend on this. You see the lattice-based schemes, and their security is related with the learning with errors problem in different groups, module-based, ring-based, and the other things, and learning with rounding problem, NTRU, the hardness of the NTRU. For the code-based schemes, we are looking for the copper codes, low-rank codes, or short-humming weight. The other things we are looking for and in the next round, some of them was eliminated again, and we are receiving the smaller list for this, and NIST select only 15 of these algorithms for the second round, and they are 7 of them was selected as a finalist, 8 of them was selected as an alternate candidate, and their aim is for this round general purpose algorithms. And for the general purpose algorithms, lattice-based schemes are the most wonderful candidates for this. If you select the hard problems, then by using those hard problems, you can generate key encapsulation mechanism and digital signature scheme. And we are looking for the further improvements as well. If the scheme has a problem, can we modify this one? They are looking for the this idea again, and they check at this time the performance issues. If your scheme is not giving a nice performance, then it was not selected. And also they are looking for some real-world usage ideas, and for instance, SSL certificate, DNSSEC, IPsec, SSH, and the other things. And they also check constant time implementations to prevent software attacks for different processors. And the computational efficiency is another concern by NIST. Their aim is to reduce the risk of the other attacks, which we have seen in RSA implementations, the Feynman or the elliptic curve implementations from the implementation attacks. And they have some general purpose usage and the special purpose usage. For the special purpose usage, we have different algorithms, and these different algorithms can be specialized. For the general purpose, you can use everything. And I will repeat the same thing. NIST do not want to put all eggs in one basket. They are looking for the other things. In the third round, we have the number of the algorithms is very low, and those are selected as the candidate for the standards. And according to these results, we have so many new ideas for this, and they are the very efficient schemes. And the selected algorithms was announced in 2022, Kyber, Dilithium, Falcon, and Sphinx. Here, Kyber, Dilithium, and Falcon are the lattice-based schemes. Sphinx is the hash-based schemes. And only Kyber was selected as a key encapsulation mechanism or the encryption scheme. The others are the digital signature schemes. We have a standards for the Sphinx and the other things which is given by NIST. And we have the alternate candidates for the NIST submissions by Macalis, HQC, and Psych. Here, by Macalis and HQC are the code-based schemes. Psych is the isogeny-based schemes, elliptic curve-based schemes. However, Psych is not secure anymore. After the announcing this list, Psych is insecure now, and you cannot use. It is not recommended to use Psych for this. And at the end, you see the long-term security issues and the implementation issues are considered, and we are looking for the practically efficient schemes from different families of crypto systems. This means that NIST do not want to put all eggs in one basket. In short, we can see like this. We are looking for the all phases: key generation, encryption, decryption, or signature verification. Signature generation and the verification should be efficient, not only one side. And the poles are selected as a general purpose usage. And we have some problems in the lattice-based schemes, usage of the keys from the generation and the life of this one. And we also see that some algorithms are selected according to their performance results. And we know that according to the NIST report, they don't have any security problem. However, they were not selected. Why? First of all, they are not easy to understand. They are not simple, and they don't seem that they are flexible, and their performance are not as good as the others. So they were not selected. Falcon and the Picnic are the examples for this. And another thing is that lattice-based schemes have been studied. However, they are not studied in a deep level. And the hard problems we are looking for, the LWE is widely studied, although it was proposed only 20 years ago. And also we have new problems from LWE, for instance, LWR problem. So LWR problem is very new, and the NIST does not trust the security of the LWR problem. So one algorithm, Saber, was not selected by NIST. Kyber, whose security depends on the LWE problem, was selected instead of Saber, although Saber has a good performance. And we can think about like this when we take the sizes for the signature algorithms. When we compare with the RSA and the elliptic curves, you see that the algorithms for the post-quantum world are not as efficient as the traditional public key schemes. The key sizes and signature sizes are not as good as. In one case, if you optimize the key size, then the signature size will be very high. We have the same thing for the other things. So the lattice-based schemes are the most popular ones when we think about the public key and the signature key sizes. And they are very close to other things. At the end, what do we think about what does NIST want? They are looking for the security from the theoretical side and the applied side. And implementation attacks should be considered as well. And they are looking for the performance. The performance of the algorithm should be nice in software and the hardware problems. And we shouldn't check everything only in one side. And we need to think about the other things. And also, what does the industry want? If the industry does not think that those algorithms can be used in the platforms, in the products, then they will not use those algorithms. They are always looking for the performance, key sizes, and when we think about our mobile platforms and the other things, energy consumptions is very important. This is related with the performance, but those are not the same thing. Energy performance should be low, since we are using sensors, Internet of Things, and so many devices in our daily life. We have to use those algorithms, and they shouldn't produce so much. They shouldn't consume the energy so much. And we have to find some ideas. And also, bandwidth level is very important. If you are using very large public key sizes and you have to deliver it all the time, does it make a problem? And think about your SSL connection with your email server. And so many people are using the email at the same time. And if the public key is very large, if you think about those are in kilobyte levels for each user, then we will have so many problems. And since we don't have so much time, I am passing the technical details for the algorithms, and I will come to the end. We have the signatures selected for the standardization shipping plus, and we know that there is no known attack for the shipping plus. And we need to think about in the future, the researchers think about this one. We need some time to understand the schemes and to complete the process of the house quantum algorithms. And the time is very fast, but we don't have so many research for this. And we are looking for the new chances to innovate, to understand the schemes. Much more research is needed, in short. And we see that Rainbow was broken, Psych was broken within months, and they can be broke by using your laptop. And we are looking for the next algorithms to see the other things. And NIST has started a new competition for the short signature and the fast verification algorithm. And this process will be completed within 2 years. We are looking for like this. There are so many submissions for the short signature and the fast verification algorithms. This is the digital signature one. And this is the special purpose algorithm. And you will see that we will have different things for this. For instance, this can be used in DNSSEC applications. Public key and signature size should be small for the DNSSEC application. And what are the next steps for the post-quantum algorithms implementations and the usage in general? The key formats are not defined in a nice way. According to the draft standards, we have so many problems. And we don't know, in general, we know, but for the software and the hardware problems, for the most efficient way is not known how to store, how to load the key from key formats and the ordering issues. In protocols, we have to order the steps, phases. So how can we do this one? And interoperability is the very big problem. Now you are using RSA and I am using lattice-based schemes, post-quantum schemes, how we can understand each other. So the selection of the algorithms and interoperability is another big problem. And we are waiting for the migration report from the National Institute of Standards and Technology in 2024, and we will see that how we can migrate to the post-quantum algorithms. We will start in this year, and we will see so many problems and how we can improve this one. Those are the open problems for the next years. I want to thank you for your attention. If you have any remarks or suggestions, those are welcome. And I would like to thank the organizers from Debasis to other professors. Thank you very much for your invitation. If you have any things.
Hello, Professor. Are you able to hear me? Hello. Hello.
Hello.
Are you able to hear me? Are you able
Yes,
to
I
hear?
can hear you.
Yeah. So I have a few questions. So you talked about multivariate quadratic polynomial problem, right?
Yes.
Yeah. So
Yeah.
we all know very well that it is a NP hard in almost all fields. I just wanted to know what polynomial time solvable versions of this multivariate quadratic polynomial problem uh, could be applied to post-quantum cryptography.
Yes, you can use this one, but you have to think about the encryption should be easy and everything can be performed in a reasonable time when you compare with RSA. And in milliseconds, you have to complete the encryption and the decryption side. And what are the parameters you want to use this one?
So,
And everything is related with the performance. And those are very interesting issues. And we will see in the short signature and the best verification algorithms, multivariate base schemes. And the solution is very basic for this. And you fix some elements, you give random results, random values, random parameters, then you solve the linear equations here. I think it is much more clear for you.
Yeah, so we all know that it depends on the number of variables. As you said, it depends on the number of parameters such as the number of variables and degree of polynomials, as well as the
Yes.
number of equations and also the size of the base field. So my question is, now this post-quantum cryptography, we all know that it is a hard problem, but what about Ramanujan expander graphs? Now being largely looked at for solutions of some of the problems of this post-quantum cryptography. Do you have any idea about to say something about Ramanujan's expander graphs?
Yes, in theoretical way, it is possible, but if you expand S1 to the other things, you have to be sure that the efficiency should be satisfied. If you don't provide the efficiency, then those are not meaningful for the crypto side. And first of all, it should be secure. Then you have to check the implementation performance. The performance results are very important for this. And there are so many ideas to combine the different things in the multivariate base schemes, and they have some security problems. You have to follow the roadmap for this.
Do you have right now any Ramanujan expander graph type results for this post-quantum graph cryptography? If you have, can you show one or two results here? If you have any
I
idea?
don't have, yeah, I don't have here, but we can discuss it later. If you send me an email, then we can discuss it in detail.
Okay. So any more questions from the audience?
Siddharth, I'm Debasis here. How are you?
Hi Debasis, how are you? Thank you.
I am fine. Because you see, we are expecting your physical presence, but due to some reason, we are unable to come. Hopefully, we will
Yeah,
meet sometimes in the near future.
yeah. In the next year we will meet again. Don't worry.
Okay,
Don't worry.
okay, okay.
This year we have some problems, but in the next years we will be okay. Yeah, thank you very much. I hope you are okay and your family is nice.
Professor Sadat, I am the Dr. A.K. Narayanan, the organizing chair, who has been communicating with you. So we will be very happy to host you to our university campus shortly. Please be
Okay,
prepared
thank
to
you very
visit
much.
us. So we will be very happy to host you here, and we really enjoyed your very high quality talk today. It was very interesting. So we will keep in touch with you for our future assignments. Thank you very much
Okay.
for your wonderful talk.
Thank you very much for your emails
Yes.
and we talked from the mails and thank you very much for your nice.
Yeah. Thank you, sir, Professor. Thank you.
Okay.
So let us give you a good applause for Professor Sadat.
Have a nice day. Have a good event.
Yeah. Okay. So let us go to the next invited talk of this session. Um, the Professor Brian Freeberg is held up in Germany due to some e-visa problem, but he hoped to get it soon, and he may not come here for the conference today, but there is a possibility that he may visit us by 9th or 10th for a special invited talk as my visitor to mathematics department. He may come. So let us have a arrange for that. So he will be staying with me for a few days next week. So now, for this session, I have to fill it up with some invited speakers. And readily, Dr. Debasis Giri, who is also a program chair of this series of international conference, and also he is a co-founder of this series of conference. So it is, so he has come to our rescue by offering that I could give an invited talk in the slot left vacant by Professor Brian Freeberg due to unexpected reasons. So I am very happy that he has accepted. So only yesterday around 9 o'clock I informed him. So he said, okay, no problem. I will take another 1 or 2 hours for some preparation and I will give you a talk. So now that is why sorry for not being able to give you the title and abstract of his talk. So he will now, I give the stage to him and he will be delivering his invited talk during this session. So on behalf of all the attendees here, I welcome Professor Debasis Giri to take over the stage and deliver his invited talk. So I am very happy because he is my good friend in the past 1 year. He has become my brother. He is my brother and he is my good friend. So I am very happy to say a few words about our program chair, Dr. Debasis Giri. So Debasis Giri is now working as a professor in the Department of Information Technology of Maulana Abul Kalam Azad University, West Bengal. Prior to that, he was a professor in computer science and engineering, and he also served as a dean in the School of Electronics, Computer Science and Informatics at Haldia Institute of Technology, Haldia, India. So he did his master's. He did both MSc and MTech from IIT Kharagpur. And he has completed his PhD also from IIT Kharagpur. And he is a 10th All India rank holder in GATE, Graduate Aptitude Test for Engineering in 1999. So give him a good applause. So he has published more than 100 papers in reputed international journals and conferences. His current research interests include cryptography. That is why he is in touch with scientists from in the area of cryptography. Professor Sadat is one such eminent person. So his interests include cryptography, information security, blockchain technology, e-commerce, security and design, and analysis of algorithms. He is also an editorial board member and reviewer for many international journals. He is also a program committee member. He is also serving as a program committee member in various other international conferences other than his own. He is a life member of Cryptology Research Society of India, Computer Society of India, and International Society for Analysis and its Applications and Computations. And he is also an IEEE member. So with this brief introduction, I welcome Dr. Devasis Giri to take the stage and deliver his invited talk.
Hello. So thank you, the organizing chair give the opportunity to give my invited talk in this platform. So today's talk on authenticated encryption on fixed and arbitrary length of message and its applications. Today, internet plays an important role in communication. To keep information secret and transmit securely, cryptography plays an important role. Cryptography is basically a mathematical concept that can provide authentication, digital signature, access control, and so on. There are three types of security primitives. One is unkeyed primitive, symmetric key primitive, and asymmetric key primitive. Unkeyed means there is no concept of key. For an example, cryptographic one-way hash function. Symmetric key primitive, that means in the symmetric key primitive, one key used for encryption and another key used for decryption. Sorry, same key used for decryption. But in asymmetric key primitive, one key used for encryption and another key used for decryption. So example is say RSA crypto system, that is the famous crypto systems invented by three scientists, Rivest, Samir, and Edelman. So let us go to the next slide. Next slide. Okay. So this is my skeleton of my talk. I will first go to the introductions, background information, and overview of the existing protocol, design of authenticated encryption, analysis, and finally conclusion is there. So go next. So authenticated encryptions means it is sometimes called a encryption. Encryption means you can encrypt the message using the public key crypto system or symmetric key crypto system, but here we will talk about the public key crypto systems. So sender can encrypt the message using the public key of the receiver, and receiver can decrypt the message. Where in digital signature, signer can sign a document with his or her private key, and everybody in the network can verify the signature. What is authentication? Authentication is a this one. Which one? This one. No?
This one and this one.
This will. Oh, okay. And marker. This one.
Marker, sir. Lighter.
Lighter. Which one?
This one, sir.
This one. Okay. 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 So in authentication is a protocol that can verify a message has come from allied source or not, or a message has been altered or not. Authentication can be done through the digital signature. So here in encryption or authenticated encryption, we are two protocol using in a same protocol. In some encryptions, we can sign the message, then encrypt, or first encrypt, then we can sign. If you use the two protocol, then it computational cost will be the more. Instead of that, we merge them and convert it into a single protocols that can take the less computational as well as communication cost. So, in 1978, first digital signature has been invented by three scientists, that Robin, Samir and Edelman. And after that, algorithmic crypto system which has been invented in 1985. First encryption algorithm is designed by the Zheng et al. In 1997. After that, many authors proposed many authenticated encryption schemes, and there were some drawback, and then to overcome the drawback, many authors published the many papers. Around we see more than 2,000 to 5,000 papers are there on that area. So, before going to describe a protocol, let us describe the background. You see, let n is a natural number set, n belongs to n, and define Zn equal to 0 to n minus 1, and how we can perform addition, subtraction, multiplications over modulo n. Because here we are considering Zn, the element should be 0 to n minus 1 and operation will be taken over modulo n. We define a plus b modulo n, that is the simple thing. We see that will be the a plus b if a plus b is less than n, and if it is greater than n, then you can just subtract n from the addition. Same way, in subtract that, so that the result value will be lies in Zn. In subtraction, a minus b is greater than 0, then it will be the a minus b, and if a minus b is less than 0, then you can add n, so that value should be belongs to Zn. And multiplication can be defined ab mod n equal to remainder ab remainder n. That means we can already, these are the simple things we have already known about the remainder. We have studied in class 10. Say, suppose we have n, we have a number n and a, and we want to find the inverse of a over n. Say, suppose I am telling that, say, what is the value or what is the inverse of z, or what is inverse of 5? What can be the inverse of 5? The inverse of 5 can be under multiplications 1 by 5, isn't it? But you see, here we are not telling the domain. Here not, we are telling the domain. What is the domain and what is the codomain? But here our element Zn, that is equal to 0 to n minus 1s. That means we will perform the over modulo n. So, inverse of 5 over modulo say suppose 7, that cannot be the 1 by 5. That can be the, because you see 1 by 5 does not belongs to Zn. Okay. Inverse of that can be something different, that can be some values. So, you can use the equivalence algorithm to find the inverse of say 5 over modulo 7. Okay. And you see, if GCD of a n equal to 1, there should have unique inverse of a over modulo n. If GCD is 1, then you can have inverse, that means inverse will be exist, unique inverse. Now, there are some intractable problems, hard problem. Here we will describe two intractable problems. One is discrete logarithm problem, another one is computational Diffie-Hellman problem. In discrete logarithm problem, suppose p, small p belongs to a set capital P is a prime number set. And G is a generator. Given G to the power A modulo P, find A. Okay? Here, given G to the power A modulo P, it is computationally infeasible to find the value of A due to the discrete logarithm problem. Our computer can compute maximum 2 to the power 80 operations. It is assumed. Still the high computing power environment, we can assume that our computer can compute maximum 2 to the power 80 operations or maximum 2 to the power 80 steps. Okay. When P is 1024 bit number, then our efficient algorithm can solve this problem and it will take around 2 to the power 81 operations. Okay. So that is what? That is the more than the 2 to the power 80. That means that is computationally infeasible. That is computationally infeasible because it's still now we are having the efficient algorithm, number field sieve method, polar row method and so on. If our P is 1024 bit, it will take approximately 2 to the power 81 operation. That means that is more than the 2 to the power 80. That means we can say that it is computationally infeasible. If you consider P is 512, that can be less than 2 to the power 80 operation. That is computationally feasible. If you increase the size of P, security will be more. That will be more harder to. But still now we are not having the solutions because you see, probably you know that. Say if I want to factor of n, how can factor of n? You can use one for loop for I equal to 2 to n. If n is divisible by I, then I is a factor. This is the simple thing. What can be the steps required for this one? N steps. For I equal to 2 to n, maximum n steps. Okay, but you see there is one more efficient algorithm. What is that one? We can start from 2 to root over n. Then also we can find the factor of n. That is more efficient than the previous one. There exists more efficient than that one. Polar row method and that number field sieve methods. They are more efficient than that. Still now these are the efficient algorithm. If tomorrow say somebody invent that you see even our P is 2024 bit number, then also that can be solvable in 2 to the power 8, less than 2 to the power 80 operations. Then that will be no more secure. Then you have to increase the size of the P. It is if that quantum computing is invented, then factorization problem will be the easier. That means the factorization, the RSA crypto system is, security of the RSA crypto system is based on the factorization problem. Then RSA crypto system will be no more secure. But security of say algorithm crypto system that is not based on the factorization problem, that is based on the discrete logarithm problem, that can be the secure. Okay. And in computational repeatable problem, P belongs to P, G is a generator. Given G to the power x and G to the power y over modulo P, compute G to the power xy over modulo P. That means you see, if our P is 1024, at least 1024 bit number, then given G to the power x modulo P, given G to the power y modulo P, it is computationally infeasible to find G to the power xy over modulo P if P is 1024 bit number. That means that will take more than 2 to the power 80 operations. Okay. That means you see these are the harder problem. Our P should be at least 1024 bit number or more than that. We can define the authenticated encryptions. This is the tuple of algorithm, key generation, sign and encryption, and then decrypt and verify. Okay, 3 algorithm. The authenticated encryption based on the 3 algorithm: key generation, sign and encryption, decrypt and verify. How can key generation algorithm is basically one randomized algorithm that will take K is a number, that means our key length would be K bit in terms of bit. That can be sometimes a standard notation 1 to the power K we can write. Okay, and that can produce SDK and VEK. SDK is the signing and decryption key, and VEK is the verification and encryption key. Okay, SDK is the signing and decryption key, because you see that means that should be the secret. When I want to encrypt the message and send to you using your public key, that means you can decrypt the message using your only secret key. That secret is kept secret by you, and public key is placed in public domain. Everybody can access. So here SDK is the secret key, but VEK is the public key. We can have the message M, and we want to generate the signature. So how can generate? I can use your public key, because I do not know your private key. I want to generate the signature. Who will generate? Because I write some document and then I put my signature. That means that document is authorized by. Okay. So when I want to sign, that means I can use my private key. When you want to send encrypted message, I can use your public key. You can decrypt. Okay. So here we generate a message M and use your public key and use my private key. That means I will use the secret key and of mine and public key of you. Okay. So that here there was, say suppose two parties A and B. So A can run this key generation algorithm, B also run this key generation algorithm. So SDKA and VEK is the private and public key of the user A. Similarly, SDKB and VEKB is the private and public key of the user B. So here we use my private key SDKA and use, it is not visible, and use your public key, you are the B, VEKB. Okay, and that will generate the signature S. Here you see, I am sending to you. Okay, so only you can recover the message from the encrypted message, and you can only verify. Nobody else can verify that message or recover the message. Okay, but in digital signature, in general, normal digital signature, there are variety of digital signature. Say normal digital signature, ring signature, proxy signature, hierarchical access signature, and so on. And authenticated signature is another one. In authenticated signature, in the normal signature, I can sign the document. Everybody in the network can verify the authenticity of that document. But here, I can sign the document. Only you can verify. Decryption and verify. Here we will take the signature, and you can use your private key and my, that means signer, public key. So that is what here you use. VEKA is the public key of mine, that means I am the signer, and you use your secret key SDKB and signature, and then first recover the message M and then can verify. Okay, that depends upon. Sometimes you see you verify, then recover the message. Here, in all digital signatures, for better security, we can use the hash functions. Hash function is basically here we can talking about the cryptographic one-way hash functions. Okay. In cryptographic one-way hash function, they are having the 4 properties: easiness, one-wayness, collision resistant, second p-image resistance. Okay. Easiness means if I give input, it can easily give the output within few seconds. One-wayness means if you give the output, that means hash value, it is computationally invisible find the what can be the value. That means say here, given C belongs to Y, here is 2 set, X is domain set and Y is codomain set. Given C belongs to Y, it is computationally infeasible to find a message M where M belongs to X such that C equal to HM. That means reverse is computationally infeasible. Collision resistant, it is computationally infeasible to find 2 different messages so that their hash value are same. Second p-image resistance, we are supplying one message in a domain set. Okay, we have to find another message so that their hash value are same. That should be also computationally infeasible. Then we can say that that is cryptographic one-way hash function, because you have studied the hash function in the data structures, but they are not the cryptographic one-way hash functions. To design a protocol, we require some so that the protocol do not have some attacks. Here is totally break, because if I know the private key of the signer, then that system is totally break. A computes the secret tab door or secret key, then the adversary can generate the signature on behalf of key. So that type of attack is called the total break. Universal forgery, a finds a efficient algorithm that is same as the algorithm used by the signer. Equivalent algorithm. Say for an example, say suppose I want to add A plus B modulo 2, that is equal to A exclusive or B. That means the algorithm are same, but we do not know the key, but algorithm are same, equivalent algorithm. Then that type of attack is called the universal forgery. Selective forgery, it generates signature on a particular message, not all message. I generate signature and verification process cannot detect that. Existence forgery, if a attacker forge a signature on an arbitrary message. Above one, selective forgery, that means some particular message, here arbitrary message without knowing the secret key. Modify of signature, because if you only send the signatures, that can consist of 3-4 parts. We can change 1 or 2 parts, but verification process cannot detect. So every day you are using these type of protocols. You see, when you go to the when you want to withdraw the money from the ATM card, you put into your card reader, then supply your PIN. Then your machine will generate, that means ATM machine generates some information, say 4-5 information, that goes to the server. Server is verified whether you are actually user or not, because you see based on your PIN code, the machine generate the informations, that information goes to the server and server verifies whether actually user or not. But you see that information, if you today you generate the some information and tomorrow you are generating other information, they cannot be the same. If time is different, the message will be the different. Otherwise, there is also some other attacks, that is called the replay attack. To avoid that replay attack, the message can be generated differently for different time. Here existing one protocol, algorithm signature. Let P be a prime such that P minus 1 has a large prime factor. If P is prime, say suppose we can consider that say 11. Okay. So, p minus 1 is 10. So, 5 we can consider that is large prime factor, because here p is 1024 bit number, you have to keep in mind, but this is small example I am telling. So, 5 is another one prime factor, we will not consider 2. And G is a primitive element, G is a generator. Okay. Suppose there exists user A, X is the private key of the user, and then its corresponding public key can be G to the power X over modulo P. So, that means Y is the public key and X is the private key of the user A. So, how you can generate the signature? A randomly select a message, choose an integer k randomly from 1 to p minus 1 and compute r equal to g to the power k and s equal to m minus xr into k inverse modulo p minus 1, because you see Professor R.K. Sharma, he has taught and given one theorem, Fermat's little theorem. Okay. That can be verified, because that verification process will be verified based on that Fermat's little theorem. Okay. In Fermat's little theorem, say if GCD of a n equal to 1, then a to the power and n is prime, then a to the power n minus 1 equal to 1 modulo n. If it is not prime, then we can say that if GCD to the power a n equal to prime, but n is not prime, then also a to the power phi of n equal to 1 modulo n, that is called Euler's theorem. Okay. So, they are we can verify the process based on that, those theorems, but here we are considering the p is the prime. Okay. Okay. So, we compute r, we have select k, compute r equal to g to the power k modulo p, s equal to m minus xr into k inverse modulo p minus 1. Okay. So, here you see we are sending ARS along with M to a receiver. This is the signature on the message M. Now, you consider say line number 2, say RASM, they are sending over the public channel, not secure channel. So, adversary can trap the message. So, adversary knows what is R, what is S and what is M. Adversary knows the protocol used, that means adversary knows what is G and what is P also, and what is the public key of the signer, that is put into the public directory, isn't it? Clear? So, here we can verify whether R to the power S and Y to the power R equal to G to the power M or not, because you see here, from here we can check easily. Here S equal to, we have S equal to M minus R x k to the power minus M modulo P, and here R equal to G to the power k mod P. Oh, this is P minus 1. P minus 1 means here this way, not first mod P then minus 1, no. Okay. Now, if you take this, you can write this one, say Sk plus Rx equal to M over modulo P minus 1. If you take G to the power, then here will be G to the power x Sk plus Rx equal to G to the power M. You see that was at this side, at the exponent part, and here should be modulo So this value equal to what? What is g to the power k? G to the power k equal to r. So this equal to, we can write r to the power s. What is g to the power x? G to the power x is equal to y, and this is r, that is equal to g to the power. So this is the verification process. If verification, and so this is correct. So if this is correct, then we can say that that is verified, otherwise the message is rejected. Here you see, you check the line, this one, 2, from r, that means r can be tapped, that means g to the power r equal to g to the power k mod p. So from g to the power mod k p, it is computationally infeasible to find what can be the value of k due to discrete logarithm problem. Already mentioned earlier. So g to the power k over modulo p, it is computationally infeasible to find what is k. So from these equations, we cannot find what is k. Now let us consider the second equation. S equal to m minus rx into k inverse mod p minus 1. So in that equations, how many unknowns are there? In the first equation, unknown, how many unknowns are there? R equal to g to the power k, one unknown, one equation. Still now we cannot solve what can be the value of k due to the discrete logarithm problem. In second equations, how many unknowns? One equation, how many unknowns? Two unknowns. What the information known to the adversary? You see, m is known, r is known, s is known, g known, p known, and y is also known. Y is the public key of the signer. Okay. So p known, that means p minus 1 known, s is known from the tabbed information, m is sent over the public channel, so m can be known, r is also known. Only unknown are secret key x and the random secret, k is the random secret, that is k. So one equation, two unknown. How many solution can be there? Say suppose if I consider, say y equal to ax plus b. So how many solution can be there? Infinitely many solutions. Okay. If I say that y equal to x plus b modulo p, how many solution can be there? That should not be infinite. Okay. That can be maximum p solution. But if p is large, so 1024, that can be approximately 2 to the power 1024 number of solutions, but that is to find one solution, that means to find the exact solution from there, it is very much difficult, which can satisfy both the things. Okay, that should be the computationally infeasible. Okay, so that is what from here we cannot find what is the aim. Who cannot find? Adversary. Adversary cannot find. We cannot say cannot find. It is computationally infeasible to find the aim from the tapped message and public informations. Okay? Clear? Now, that algorithm is having, that protocol is having one drawback. Suppose M1, M2, M3 messages are there. We have selected K1, K2, K3 at the random number for generating the signature. Okay. M1, M2, M3 at the message, K1, K2, K3 at the randomly selected message. So then here you see, if you put K1, then you can say that that is R1. Okay. Here if you put R1, M1, then you can say that that is S1, so on. That means we are having three signature. on 3 different messages M1, M2 and M3. Okay. Now, if it satisfies R3 equal to R1 plus R1 into R2, that implies that K3 equal to K1 plus K2. Okay. If R3 equal to R1 or R2, then we can say that K3 equal to K1 plus K2. Then we can find what can be the secret key of the signer using this formula. Okay. Then the system will be no more secure. But we can say that that is the drawback of algorithmic digital signature. But we cannot say that discrete logarithm problem has been solved. This is one drawback. But we cannot say discrete logarithm problem has been solved. Or we cannot say the system is baked. Because you see here K3 equal to Q1 plus K2. We cannot find such type of 3 numbers such that that will satisfy. Because when you generate the random number, there should have random number generator. That is what information we will get, we do not know. We cannot put that 5, then 10 and then 9. Random number is having some property. Number of zeros and number of ones should be the approximately same. And there should be the no repetition of the pattern. Say suppose 3 1 then 3 0 and later sometimes 3 1 3 0, that should not be repeated. There are other tests, die-hard tests and so on, because you see that is what we can say, that it is hard to find three messages so that K3 equal to K1 plus K2. But if you find, then you can find the secret, but it is very hard. This is one drawback of the system. But here we see, we can generate the signature on the fixed message length. M should be lies from 1 to P. To generate the arbitrary length of message, instead of M, we can use H of M. Then we can generate the. But how we can overcome that situation? To overcome that drawback, you see here, instead of M, if you write hash value of M comma R, then we can overcome that drawback. Anyway, I am not going to describe details on that. Now, let us describe one authenticated encryption. So, it consists of 3 pages: setup, sign and encryption, decrypt and verifications. Okay. So, there should have some central authority that selects large prime PQ such that Q divides P minus 1, and select alpha belongs to ZQ, that should be the primitive element. Okay. And if there exists 2 user UA and UB, then their secret key can be alpha A and alpha B, and corresponding public key can be alpha to the bar XA and alpha to the bar XY modulo Q. Okay? Sorry, modulo P. These are the public key. Now, how can generate the signature? Here we select a message, select, because you see why I am describing that algorithmic crypto system, that is basically based on that type, that is what. So, here we can select K, that is belongs to 2 to Q minus 1, and compute T equal to HM, and compute R equal to M YB to the power K modulo P. So, here you see from the equation 1 cannot find what is M, because the H is a cryptographic one-way hash function. Okay. Reverse is computationally infeasible. Given T, it is computationally infeasible to find what is M. consider this equation 2, m that is multiplied, that is random factor is multiplied, yb to the power k. Yb can be the public, but k is the random number. So, yb to the power k is some random number. So, from R one cannot find what is m. And then compute S equal to k into R plus xa whole inverse modulo q. Okay? And send RST to the user B. You see, in algorithm digital signature, along the RS, we are sending the message M itself. Okay. But here not sending, because you see that is authenticated encryptions. Message will be recovered, then verify. But for that case, only verify the message. Here, how you can decrypt and verify? You see, M can be recovered using the formula 4, R into IA into alpha to the power R into whole to the power minus S XP. And the correctness can be done here. We can prove that one. That is correct. Okay. So, after verifications, after recover the message, I can check whether value of T is equal to hash value of M or not, recover message M or not. If it is satisfied, then it is accepted, otherwise it is rejected. Clear? Now, this protocol have some constant. So, here for generating the signature on different message, we cannot use the same key. The key should be the different. Otherwise, we can recover the secret key, key, even secret key from these two equations. Okay. So, k can be for generating the signature, k can be the different. Remark 2, if the signatures RST and R-ST of two different distinct messages M and M dash collides, collide means the hash value are same. But we see this is thus the different message, here is different message produce the different signature. Different message, if you consider the two different message, that can produce the different signature. Because you see the previous case, we can sign keep the fixed length message. M can be fixed, because you see here we multiply, here we multiply M. Okay. So, M should be lies from 1 to Q, so 1 to P maximum P, not P, less than P. Okay. That means length of M is fixed, but that is not arbitrary. So, we can write in protocol in different way, so that can consider or that can provide the authenticated encryption on arbitrary length of message. So, the step setup phase is same as the previous one. Here we consider the message arbitrary length of message M 0 to 1 star, 0 to 1 star, and random secret key is selected from 2 to Q minus 1, and we divide the message into n blocks, and each message block length should be less than mod Q minus 1, so that it cannot more than the modulus Q, mod P minus 1, okay. So that it cannot more than that, because our modulus is mod P. If you consider, say, suppose modulus is 5, if you consider, say, 12, that is more than 5. So, if you want to recover the message, then you have to put another parameter. So, that is why in general, to avoid that situations, we consider the message should be less than modulo 5, less than 5. Okay. So that no other parameter should be provided. And then we compute t equal to hash value of m1, m2 to up to mn, then compute r0 equal to t into yb to the power k, because you see here first we compute t, hash value of the message, then compute r0, that is t multiplied by yb to the power k, because in the previous case that was multiplied, instead of t we put m. In the previous case we put m instead of t to compute r. And then we compute Ri equal to mi into hash value of yb to the power k modulo p concatenation I whole over -1, that means inverse of that one, modulo p. Here to recover the message mi, because you see here we are multiplying the mi. If you want to recover the message, then first you have to, what we have to do? We have to compute what is t. After that, we have to compute what is yb to the power k, because you see, if you know the yb to the power k here, then you multiply that value with ri, then you can recover the mi. So our first target will be how you can find yb to the power k. So if you want to find the yb to the power k from the r0, we need what is the value of t. How can recover the t? That means we have to know the whole message, then we can only recover the t. Okay. Then we compute r equal to t concatenation yb to the power k, then concatenation r1 to rn, and then compute s using this equation 9, and finally we transmit r0, r1 to rn, and then s to the user b, ub. Okay. After sending this one, we can recover the message using this formula, that can be proven. T equal to r into ya into alpha to the power r whole to the power minus s xb. Okay. So to recover the message, receiver will use his or her private key and use sender public key. So you see here, to recover the message t, basically t is not the original message, we want to compute basically t. Okay. So here ya is the signer public key is used, ya, and use the xb is the receiver's private key. So t is computed. After computing t, we can recover what is yb to the power k. Here we see t is this, r0 is sent over public channel, so t is given. So from r0 we can compute yb to the power k. If you know the yb to the power k, we can compute what is mi, because you see I also submitting over the public channel, transferring over the public channel. So we know all mi. Okay. So from there we can compute all mi. Okay. Since we know the all mi, we can compute t using the hash value of all mi. Okay. That means our computed received t and computed hash value of m1 to mn, they are same, then it is accepted. Okay. And we have already recovered the message mi. Okay. Now we need to have some evidence that there should be secure, some security protocol, security analysis should be there. We should have some evidence. What is that evidence? So, that is what here we can describe some security analysis. Let us consider the first one, the short message. The computation of the original message from the encrypted message RST by an adversary is computationally infeasible. That is our statement. Okay. We will prove it by contradiction. How? Suppose an adversary A compute the original message. Our statement is, proposition is, the computation of the original message from the encrypted message by an adversary is computationally infeasible. Now I am sending no, that is feasible. Okay. That means adversary trap the all message from the communication channel. Adversary knows the all public message, public informations. From that, adversary can knows what can be the message, original message. We are assume that. Suppose if adversary knows that message from equation 4, here you can check the equation 4 at the equation 4. I have not written. Na? Anyway. This is the equation 4. How can recover the original message for that protocol? Okay. So, if M is known, you consider the equation 4, M is known. M is known means you are assumed that M is known. Then we can show that we can solve a harder problem. What can be the harder problem I have described? Discrete logarithm problem is one. Computational defilement problem is another one. There are many more. These are proven that they are harder problem. Okay. If assume that M is recovered, then we can solve the harder problem. But this harder problem we cannot solve. That means our assumption is, but we are assuming that M can be recovered. That is wrong. That is wrong. So, this way we can prove. Just we remember this equation. From there, okay. So, here we can write Ya is basically alpha to the power xa. So, that is what we can write alpha to the power minus xa whole to the power yb. And what is alpha to the power xb? Alpha to the power xb basically public key of ub. So, okay. So, we can write yb to the power rs minus rs, that is equal to r into m into r inverse modulo p. Now, we can, that can be written as alpha to the power minus s x alpha x xa xb, that is equal to, because you can keep that in right hand side, this part. Okay. And next line we have written alpha to the power xa xb equal to right hand side. So, now we check in the right hand side, the all parameters are all in informations or all parameters are known to the adversary. S is known because you see S is trapped message, RST are transferring over the public channel. So, that can be trapped by the adversary. So, right hand side S is known, YB is the public key of B, B is known, YB is known, S is also known, M is, we are assume that recover, M can be recovered from that message, transmitted message. That is our assumption. Suppose that adversary can compute the original message. That means whole right hand part is known to the adversary. Okay. But we see what is computational defilement problem. Given g to the power x modulo p, given g to the power y modulo p, it is computationally infeasible to find g to the power x y modulo p. But here we solve that hard problem. But we cannot solve the hard problem. That means our assumption is wrong. That means this statement is correct. Okay. Now, when the closing time? Okay. Okay. So, here we can prove that without knowing the random number k, generation of a first unencrypted message using the signature message RST corresponding to k by an adversary is computationally infeasible. That means here we are assume that now that is feasible. Then we again prove that we can solve a hard problem. That means our assumption is wrong. Okay. So, we can prove using by contradiction. Okay. There are many other proofs, that means they can provide that system is secure. But we see there is also formal security analysis. This is also standard security analysis. If you solve a hard problem you cannot solve. But using that by contradiction we can prove that means we can mathematically prove that the system is secure. So, here also we can prove that, say suppose from the long message we divide the message into n blocks. Suppose we know the n minus 1 blocks, only unknown is 1 blocks. Then also we cannot find the unknown blocks. That is also can provable. So, we can compare that the existing protocols and this one, scheme 1 and scheme 2. Say T basically time required for the encryption, Jenks et al. And others protocols they are taking, say for sign and encryption it will can take T, for scheme 1 it is also T. But if you compare to the Sekor et al. And others, decryption algorithm they can take the more time than the 2T, but they are not the encryption technique for the arbitrary length of message. But if this arbitrary length of message, this can be the sign and encryption time will be taken by this amount, and right hand side decryption and verification that can be taken 2T plus n plus 4. N represents basically number of blocks. Okay. So, these are the references, and you see somebody can think about that lightweight encryption. Okay. That can be the better. So, thank you. If you have any query or question.
Good morning, sir. I am Abhishek Tripathi from CSC department, and thank you. It has been a nice session and listen from you. Sir, my question belongs to a general query that in future, when quantum computers will be commercialized, so these classical computation may face challenges, and because it is more susceptible by the quantum computer, and quantum cryptographies are having the different approach as dealing with the qubits and quantum bits. So as you are the expert on this technical subject, so I want to know what are the other possibilities by the research community where we'll have some transitional bridge methods, so we can easily transit from this classical or traditional computation to the quantum computer?
Now, you see, if quantum computing is invented, then you see there some harder problem can be solved. For an example, say factorization problem can be solved. Okay, that can be the easier. But you see discrete logarithm problem, that cannot be solved. But you see that can be the easier. But you see there are different techniques. You see GOPA code, or that is based on that abstract algebra. People are thinking that way also. Even you see security system can be designed using the geometry also, and he is telling graph coloring also.
Ramanujan expanded graphs can also be used to generate several signature schemes. So the research is going on. So that is what that is new. That is what the professor has talked in the previous.
The same method can be used for.
No, not same method. That should be the different thing. If you see geometry, if you use the geometry, this thing is not geometry. That is based on the algebra, basically.
With quantum computer, whenever we are saying entanglement, superposition, something different.
That is very different, because that can be, you see, that is what we see quantum cryptography is also coming.
But even if we are having the complex computational, it can be easily factorized large number by the quantum
Computer, yes, yes.
For the hackers, it becomes very easy.
Yeah, that is what I am telling. Na? That means if it is a factorization problem, that means RSA system will be no more secure.
Thank you.
Okay, if there are no more questions. Is there any more questions? If there are no more questions, I will thank by giving a good applause to Dr. Devashish Giri for this wonderful talk on cryptography. Thank you very much. Honor Dr. Deebalakshmi ma'am with this.
What's happening in the reverse? Thank you so much, sir.
Hello, chick. Hello. Hello, chick. Hello. Hello. Hello, chick. Hello, chick. Hello. Hello. Hello, chick. Hello, testing. Testing.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே. जनगणमन சிரமடந்தை கெழிலொழுகும் சீராரும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Good morning to one and all present here. It gives me immense pleasure to welcome you all for this prestigious gathering. The function of prayer is not to influence God, but rather to change the nature of one who prays. I would request you all to stand for the prayer.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென நிகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. A pessimist accomplishes about the wind, an optimist tries to change it, and leader adjusts the snail. I request Dr. P. Lakshmi Ma'am, Dean of SOSC, for welcome address.
Good morning to one and all present here. We have come to the end of the 10th series of International Conference on Mathematics and then Computing. Today we have gathered here for the valedictory function of ICMC 2024. On behalf of our management, Vice Chancellor, Registrar, the organizing chair, Dr. Yagna Narayanan, Dean School of Computing and Dean School of Advanced Sciences, the head of SOC departments, the head of Mathematics department, faculty members, students. On behalf of them, I would like to welcome our guest for the valedictory function, Professor R.K. Sharma, Professor, Department of Mathematics, IIT Delhi. We have Debasis Giri sir, who was the main motivation behind organizing this conference. He is a professor from Maulana Abdul Azad University, West Bengal. Welcome you, sir, for the inaugural function. Sir? Sorry, valedictory function. We have Professor Vishnu Bandyala, sir, from San Jose State University, California, USA. Welcome you, sir, for the valedictory function. Apart from the participation in ICMC, Professor Vishnu, he has visited the Department of Computer Science and he has delivered his good lecture to the CSE students also. Thank you so much, sir, for that. And I would like to welcome the organizing chair, Professor Yagna Narayana, sir, who was the main man behind this show, almost working hard for the past 1 year, along with the internal team as well as the external team. He was the man, like it's like a star topology. He is in the middle and all of us are actually connecting to him. The work extended by Professor Yagna Narayana sir, it cannot be stated just plainly in 1 or 2 sentences, sir. Thank you so much, sir, for organizing this conference in the Karai campus. We welcome you. I also welcome the head of the departments, the faculty members of SOC departments as well as the mathematics department, the participants across the globe. We can see many participants from Japan, Singapore, Philippines, Dubai, and some of the other online participants also from abroad, as well as the participants from various parts of India who have come here to present your papers, and you have presented successfully also, maybe waiting for the waiting to hear the best paper award moment. You all are waiting for that. So on behalf of the ICMC committee, we welcome you also. Finally, the student members from SOC department as well as the mathematics department, you have extended a great cooperation during all the keynote session. Today also we have students from CAC department. Welcome you student members also. Once again, thank you for being with us, and once again I will extend a warm welcome to all the people who have gathered here for the valedictory function. Thank you.
Thank you, ma'am. Now I would like to call upon Dr. V. Yajnanarayanan, sir, Organizing Chair, ICMC 2024, for technical summary of the proceeding of the conference.
Good morning to one and all present here. It is really a fantastic moment for me, and normally I am not very comfortable with keeping some material to for giving a talk, because mostly I prefer to give my talk without any paper and other things. So if I carry any paper, then it gives me a little inconvenience. But anyway, I cannot do it now without some bit. Okay, so I am going to restrict my address to the totally technical input that we have generated in the past 1 year. So I have already mentioned in the inaugural address that many eminent personalities from all over the globe, especially from Massachusetts Institute of Technology, MIT. So it is a dream for many of us, many of the youngsters, to get secure an admission in MIT. So we had Muriel Medard, Dr. Muriel Medard, a distinguished professor from Massachusetts Institute of Technology, has delivered a wonderful piece of talk yesterday. And then following her, we have other stalwart lectures from professors like Dr. Bhavani Duraisingham, Dr. Ram Mohana Rao Kotagiri, the former from USA and the latter from Australia. Then we also today had a very wonderful talk by Professor Sedat from Turkey, Professor Ekrem Savas also from Turkey, and several prominent members from institutes of national importance such as IIT Delhi, IIT Kharagpur, IIT Kanpur, IIT Madras, and Maulana Abul Kalam Azad University, IISc Bangalore, Icmc, Institute of Mathematical Sciences, Chennai Mathematical Institute. So we have covered mostly the prominent institutes of national importance for education and research. So much work has undergone for arranging all these invited speakers from top-notch institutions all over the world. The response was okay, very good, and we were able to generate 285 research articles. But in order to satisfy certain norms of Springer, and also we have to keep in mind the reputation of ICMC series of conferences. For see, FST TCS and IndoCrypt are two prominent series of conferences devoted for mathematics and computing all over India. It is happening for more than 3 decades. And along with that, even though this ICMC series of conferences is only 1 decade old, it is now being rated along with those two. And it is such a reputed series of conference. Why? It is all because of the standard they maintain in selecting the papers and recommending it for publication with the Springer. So Springer is publishing this series of conference papers for the past 9 years successfully, and the quality is the Daraga Mantra for the program chairs. So Dr. Dabazis Giri, being one of the prominent members of this program chair, and is, of course, is also a founder of this series of conferences. Dr. Ponnuswamy, Dr. Z. Quing Lin, Dr. Karuna Pandey Joshi, Dr. Jaydeep Vaidya. So all these 5 members are forming a core team, and they are called as the program chairs. So they are doing it for the past 9 years successfully. And it is their collective decision based on 3 blind reviews by professors sitting in institutes of national importance and central universities like IIT, NIT. So based on the recommendation of 3 reviewers for each paper, and then finally by the program chairs. These I have already mentioned the 5 program chairs. So these 5 people have made a collective decision on the final list of selected papers. So I take this opportunity to make it very clear that I show my hands open. I have no role as an organizing chair in the decision-making process of selecting the papers for this 2 volumes of proceedings. So I want to make it very clear. So this is the opportunity for me. So as I said in the inaugural function, we are pretty much happy that we could be able to generate some interesting and innovations, interesting results, and which we are now planning to prepare as a white paper report and to be submitted to Honorable Prime Minister of India in his office. So I just read here, I will take another 5 more minutes to read here the list of important results. So in mathematics, we have received original research articles from various areas of mathematics such as algebra, analysis, applications of fuzzy set theory, computational number theory, computational fluid dynamics, graph theory, linear algebra, numerical analysis, statistics, and topology. So the following are some of the important results presented in the conference. 1. Necessary and sufficient condition for existence of a solution set for semi-infinite tensor complementarity problem. Then second result is a fundamental solution to the 2-dimensional doubly periodic potential flow problem expressed in terms of elliptic functions. Then relationship between lambda statistical derivative and strongly v comma lambda derivative. Then uniqueness problem of nonlinear differential polynomial was handled when f of z is a transcendental meromorphic function and extended the results due to Pollack-Shao et al. Then a new hybrid Topsis and Vickar technique is developed to solve the multi-criteria decision-making problem by using the fuzzy triangular numbers to analyze the risk factors of COVID-19 and flu. Then an assignment problem was solved by various ranking procedures based on Pythagorean octagonal neutrophotic fuzzy number. Then a computational method was developed to solve 1-dimensional Schrodinger equation with cubic nonlinearity and described important physical phenomena such as propagation of classical waves in dispersive nonlinear media, nonlinear optics, and water waves. Then the eigenfunction method is employed to analyze the interaction of oblique water waves with a configuration consisting of a pair of partially immersed thin vertical barriers on the 2 sides of a bottom standing rectangular thick barrier and successfully handled square root and 1/3 singularities in integral equations. Then it is my paper. I have determined the captive domination number of flower snark graph. It is a family of 3 regular graphs. then an algorithm to find the reconstruction number of split graphs that uses only 6 cards. Then derived new bounds for the superwiner index of any tree through the total distance formula for a connected graph. Then inequalities that govern the components of a 2 by 2 P by T PPT matrices that were found with the help of leap functions. Then a novel geometric algorithm is developed for computing the generalized inverse of rank deficient real matrix. Then we found a relationship between the vector field and the Majorant function that relaxes the Lipschitz continuity of the derivative in a local convergence analysis of a family of third order iterative algorithms for singularity location defined on a complete Riemannian manifold. Then we determined the dynamic behavior of a family of sixth order derivative free iterative method and found new results on global convergence, stability and reliability with the help of the convergence plane. Then we analyzed the convergence of the overlapping iterative numerical method on a Siskin type mesh for a system of singularly perturbed convection diffusion equations with mixed type boundary conditions and proved the uniform convergence of the method in 2 steps, splitting the discretization error and the iteration error. Then a continuation algorithm was constructed to find a solution for a class of singularly perturbed nonlinear system of n differential equations with unperturbed Robin boundary conditions. Then by utilizing the Agarwal-Sood results in terms of modified lattice points, 2 new combinatorial identities concerning Ramanujan's Mach theta functions are derived using n plus 1 color partitions. Every finite M Bonaxi word has a unique representation as a product of 2 palindromes. Then we developed 2 new methods, namely LS and GRAF for concentric ellipses fitting problem under general geometric assumptions and implemented them using 3 optimizers. Also, we found an equivariant version of LS category and the topological complexity of some Z2 spaces. This is all the major important results that we could generate in this conference in mathematics. In computing side, we have received original research articles from various areas of computing such as mathematical modeling and simulation, machine learning, cloud, fog and edge computing, cryptology, deep learning and wireless network. The following are some of the important results presented in the conference from computing side. A new design is created for a microstrip rectangular dual band antenna specifically tailored for MIMO applications in the context of 5G technology. Then we developed a deep learning based differential classifier for authenticated encryptions such as TGIF, TBC, LIM, DOLEN 128 and permutations such as Spongent 160 permutation, Spot 128 permutation, TGIF, TBC, AE and Limdolan 128 AE and established that the light GBM, LGBM model stands out as the optimal choice due to its minimal parameter requirements and rapid response speed. Then while probing various models for cancer detection process, a new model called ResNet CPDS for automated CPDS system was introduced and the CVCC LinicDB data set is used for validation. So this model also demonstrated comparable performance of 98.75% accuracy and 72.04% IOU to the state-of-art CPDS. Then we also got new valuable insights into the potential applications of smart energy devices and the integration of OWL ontology and hyperledger, fabric, blockchain, and the development of context-aware smart metering systems to optimize energy consumption and to ensure secure, immutable, and traceable information storage. Then we generated key-dependent 7-bit and 9-bit S boxes for the Kazumi block cipher and demonstrated their resistance against known different fault attacks. So by the efficient hardware implementation, FPGA implementation of the proposed methodology, it enhances, we assured the enhancement of security and throughput, and it was clearly established. So these are some important results presented here and also accepted by the eminent reviewers of the participants who have submitted the papers, by the eminent reviewers from institutes of national importance. So we actually selected 49 papers, and out of that 49 papers, 40 papers were only registered, and out of that 40 papers, nearly 23 papers were presented over online, and 17 papers were presented physically here. And I thank all the delegates for submitting their valuable research work by considering this ICMC series of conference. Good luck to them for their future endeavors. And throughout, and along with this, of course, we have already 18 plus invited speakers input, technical input. So we are now planning to consolidate all of them, and along with the report discussed, along with the points discussed in the panel discussion, I think we have sufficient material to submit a white paper to the Honorable Prime Minister of India in his office. So thank you very much for your wonderful cooperation for the past 6 days, and everything has went smoothly, and I once again thank all of you for your kind cooperation. So with these few words, I conclude my technical report on the papers received for 10th edition of International Conference on Mathematics and Computing. It really gives me an immense pleasure, and it is I feel really emotional for being given an opportunity to act as an organizing chair. Thank you very much for your cooperation. Thank you.
Thank you, sir. The fragrance of flowers spread only in the direction of the wind, but the godness of the person spread in all directions. Nothing greater will be achieved without great men, and men are only great if they are determined to do so. We are delighted to have the Honorable Chief Guest for the valedictory ceremony. I like to call upon Dr. R.K. Sharma, Professor, Department of Mathematics, IIT Delhi, to address the Chief Guest.
Honorable dignitaries on the dais, Professor Vishnuji, Professor Devashish Giri, Yagnayan, Sir and Madam. And of the dais from the university, Kalasilingam University, all the heads of the departments, various faculty members, researchers, my dear friends, young students, it's a matter of great honor and pleasure to be here in the holiest of the holy land, holy Tamil Nadu, holy Nadu. It also gave me the opportunity to visit some of the ancient temples and places. So it's a God-sent opportunity. With your kind help, I could visit this place. Of course, it's a great conference that we have witnessed through 1 week. Lot of eminent excellences have been here. They shared their thought research with the young people as well. We also saw various paper presentations from the young researchers, and we like their contributions will be further enhanced and strengthened by mutual cooperation and, of course, continued collaboration that we look forward. I'm pretty sure that when you go back to your place, you will carry the message that mathematics is indeed very important, and so is its application in computing and other sciences as well. And this is indeed a very great message that I'm sure you will convey to your parent organizations and countries as well. At the same time, when we talk about the research, as I said earlier, also it is very important that we encourage the school level mathematics education so that the young kids, they actually start enjoying mathematics rather than feeling or fear or something like a phobia of mathematics, as it is sometimes expressed like that. I want to see a smile on the faces of all the people, and so it should begin with the smile from the young students when they enter, and they must be fighting for the class of mathematics. That's what I want to see in future in every school, everywhere around the globe, that mathematics is the most loved subject that turns out to be. And with your kind help, this is a dream that will, I'm sure, come true. Definitely, sooner the better. There are many other things we can keep on talking, of course, the deliberations and so on and so forth. But yes, whenever an event takes place, the ultimate thing is that the evaluation process, and that comes at the end of the event. So basically, we would like to hear from the participants who have been here all through or even for a part of it. How did they feel about it? How did they found that whether this is fruitful as an exercise to carry forward, and in what way it could be made better. Of course, Professor Nan has very nicely and very meticulously have presented the report, and he also has concluded various results that we came across. But the final word we would like to hear right from those who have done it and who would like to see it, how it progresses and how to make it better and all that. And ultimately, one more thing I would like to see is तुमसे मिलना बातें करना अच्छा लगता है. Meeting you, talking to you, seeing you is always beautiful. मिलते रहे हैं, मिलते रहेंगे, ऐसा वादा करते हैं. We have been meeting, we shall be meeting soon. That is going to happen. Thank you very much.
Thank you, sir. No, an extra. Thank you, sir. Thank you for your wonderful singing. I would like some participants for the feedback.
Participants are now requested to come forward and say a few words about your observations. So you have spent here for about 6 days. So the 4 days respectively for symposium and a conference. So anybody is there, please come forward to say a few words about your experience. We are happy to hear. Everybody is there? Any participant?
Hello, good day everyone. Sorry. I'm Nathan de la Cruz from the University of the Philippines. So I traveled solo here, so I was kind of scared because maybe this person will get lost in India. I mean, this is my first time to be here in India. And I really didn't expect that people here are very nice and very accommodating. And during my first day, most of the organizers really helped me in my hostel, my food, and everything. And what can the thing that I can say in this conference is that I think we should further mathematics because in my university, most of the students are really afraid of hearing the word math. Like mathematics is such a very, very hard subject and people don't want to take math. But I think with this conference, we could encourage students to delve on this subject because mathematics is a very, very interesting subject and it has helped many people and made life easier. And in that, also I would like to thank the organizers for organizing this event. And also, thank you for the beautiful and handsome people that I've met. And also, I've made some friends, Babita, Mom, and everyone. So thank you so much for this one. This is a memory that I will cherish forever. Thank you so much.
Hello. I am Hidenori Ogata from Japan. なんて言ったらいいか。It's the first experience for me to visit India. So I have a little much trouble. But when I in some trouble, and many Indian local people help me every time. So this visit to India is a nice experience for me. Sorry, I'm not good at listening to English.
You can speak in Japanese.
Japanese?
Yeah, please. Yeah. We will translate and we will understand later. You please speak in Japanese. We need to record it. We need to record it. So you please speak. We are willing to listen Japanese.
なんて言ったらいいかですね。皆さん親切で大変、お世話になりました。All the Indian people are very kind and help me every time. みんな助けてくれまして、そうありがとうございます。Thank you very much.
Good afternoon, one and all present here. I am really happy to share my experience in Kalasalingam University for past 4 days. The overall experience was very nice and food and environment, everything was very nice. And the paper presented in the conference and lectures are also very useful for our future work also. I want to thank everyone who are organizing this one. Thank you, sir.
Anyone else? We are happy to hear from you. Anyone else in here? External participants? Don't be shy to my student. Please.
A very good afternoon to all of you. Thank you, Salingam University, for organizing such a lovely conference here. With this organization of this conference, I got the chance to visit south part of India and visit Rameswaram, Kanyakumari, and also get the opportunity to see many temples, meet many professors, listening very useful lectures, and all the presenters, to meet everyone, making new friends. It is very pleasing moment for me to meet all the participants, all the teachers. They are very helpful. Here people are very nice. All organizing committees are very helpful in every respect. They helped us very peacefully, listen us every problem very peacefully, calmly, and solve everything. Thank you for this help.
Hello to all. I'm Sangeeta from Puducherry Technological University, Pondicherry. I have been to many conferences, but this gave me a special feeling because each and every session was organized so well, and moreover, the concept they have said has got us into a new ideas. It was a great opening for us in many fields, and moreover that they have fed even our intellect as well as our stomach simultaneously. That's the thing I want to say. And the hospitality what they have given us was entirely a different thing. And thank you for everything. And I appreciate the whole team who organized this conference in a so well manner. Thank you.
Thank you, participants, for your valuable feedback. Talent and skills are the crops that are nourished, groomed, and given all possible opportunities to grow and bloom. This is a much awaited event in every student's life, and this gives the returns to the effort put in by them throughout their academic endeavors. It is a moment full of joy and moment about pride and accomplishment. A moment celebration, it gives a sense of achievement and a sense of responsibility towards fulfillment, further commitments. It fills the heart with mixed feelings and fulfillment, anxiety, and eagerness. I would like to call upon Professor Dr. V. Ijnanarayanan sir to announce the Best Paper Award. So, please.
Yeah, so before I announce the Best Presentation Award or Best Paper Award, I would like to invite Dr. Brinda, who played a pivotal role for finalizing this award, and she will describe the methodology followed for selecting the best paper. So she has done a good homework with her team. So her team of 5-6 members sat over all technical sessions happened, especially the paper presentation sessions, all sessions, and they have evaluated scientifically by applying some procedure. She will describe about it and how she arrived at the final score. And it is her privilege. I don't want to take her privilege. I don't want to take. So she herself will announce the best paper award winner. And I take this opportunity because I got some time. So I steal this opportunity to make one statement which I made me very happy. So it is actually happened in a very informal manner. Yesterday when we were discussing, and I am discussing with my friend, Dr. Debasis Giri, so it really came out from his heart. So after this presentation, he will also address you about his feelings about this conference. But one statement he made which actually impressed me very well, and it gives me a lot of pleasure. What he said was, he has organized 9 editions, and he says that we have organized this conference in a far better manner than others. In fact, we have overtaken and put a best show as far as organizing is concerned than IIT BHU, Banaras Hindu State University. So that is the real compliment for all of us. And of course, my wife has one slight disappointment. So she told me, okay, so you have shown your many skills like writing skills, communication skills, oratorial skills, writing skills, organizing skills, administration skills, research skills. But one thing is missing for my wife. That is, she wanted me to give an invited talk, but I convinced her that as an organizing chair, I should not steal the opportunity or stand in the way of others. But definitely, I will fulfill my Mrs. Wish in some other occasion. Same series of conference will happen next year elsewhere. And suppose Debasis Giri gives me an opportunity, I will show my invited talk how I am giving and how I could match the international level scientists and mathematicians. Thank you very much.
Good afternoon to all the dignitaries on the dais and off the dais, and good afternoon to all the participants and my dear colleagues and faculty members. So based on the inputs given by Dr. Egna sir, we have actually given certain rubrics for evaluation. The evaluation were judged based on 4 important things, that is the presentation content, the organization of your presentation, the delivery of the participants, and also the quality and the impression, because on site we have a impression, so that with that we have framed certain rubrics. So for the content we have given, we have evaluated for 20 mark, that is the rubrics were the clarity, the quality and quantity, and the significance. And for the organization of the presentation, we have just checked on the layout, clarity, the topic, the purpose, and the summary of their presentation. And on the delivery, they deliver the professional confidence, knowledge, everything were evaluated. So based on that, we have evaluated all the presenters, and from those we have categorized based on the panel members' input. It was all external panel members who have judged the presentation along with our internal panel members, and the finalized report has been submitted to the chair. That's all from my side. Thank you. So from all those evaluation, we have selected Professor Vishnu sir's presentation, paper ID 104, which has been taken as the best paper, which has got the best paper award for this conference. Now I would like the chief guest to request, I would request the chief guest to give the certificate to Professor Vishnu. And one more thing I have to highlight is Professor Vishnu, as I told you, we have evaluated for 20, 10, 10, 10. In that scale, 20, 10, 10, 10, 10, we have evaluated, and Professor Vishnu has got 50 out of 50 in that evaluation. Thank you. Thank you.
So, thank you, Dr. Brinda, for accepting my request to summarize your evaluation process. I am again coming in before you to share one thing. So, the participants, external participants, and please do not get disappointed because you are competing with the invited speaker. So, our invited speaker, Professor Vishnu Pendiala, played a dual role. One is as an invited speaker, and another role is on behalf of his co-authors. He came and presented the paper, and he also participated, not dual role, triple role. So like Kamala Hassan's Dasavadaram, he is a multi-speciality, more all-in-one individual. So you have competed with Vishnu Pendiala. So that itself is a big award for you. Please don't get disappointed. So you have competed with the internationally renowned figure. So please don't have any disappointments. It is natural. It is natural that when a champion is there in the court, and champion should be the champion, and others should feel more happy for getting defeated only by a champion. So no regrets, please. Thank you.
Thank you, sir. Now it's time to acknowledge and encourage the presented participants. I request dignitary members to honor our participants. Yes, I announce the names. Nathan Chancy de la Cruz, University of Philippines. R. Kartika, Central University. S. Meena, Puducherry Technological University. S. Sangeeta, Sharada Gangadharan College, Puducherry. In Anjali, Bishop Hubs College. In Sundareshwaran, Assistant Professor Care. Sashin Abdul Sheikh, Department of Mathematics and Statistics, Dr. Vishwanathan Karad, MIT World Peace University, Pune. In Arulmoli, Department of Mathematics, Puducherry Technological University. Hedanore Oganta, Department of Computer and Network Engineering, Graduate School of Informatics and Engineering, the University of Electroeconomics, Japan. Jennifer, Department of Mathematics, St. Joseph College, affiliated to Bharathidasan University, Tiruchirappalli. S.B. Ramkumar, Department of Mathematics, Central University of Tamil Nadu. Ramkumar, sir. Ma'am, volunteer. Babita Mehta, Department of Mathematics, Central University of Jharkhand. Sham. Rupal C. Sharif, Dr. Vishwanath Karad, MIT World Peace University, Pune. Kundakarla Shyam Kumar, Kalasalingam University of Research and Education. Yeah, ma'am. Okay. Shyam. Now I would like to call upon Dr. P. Dibalakshmi ma'am, Dean of SOC, for consolidated reflection of the committee organization. Ma'am.
Once again, greetings to all. This is the time I'm taking to thank the CARE organizing committee. In many of the places we have mentioned about the general chairs, program chair, organizing chair, technical committee, reviewers, authors. We need to thank the CARE committee members also. In fact, the idea of organizing this ICMC conference, we have the general chairs, Dr. P.K. Saxena and Dr. P.D. Srivastava. And the 5 program chairs are Dr. Jaydeep, Dr. S. Ponnuswamy, Dr. Lean and Dr. Karuna Pandey, and then Dr. Debasis Giri sir. To conduct the 10th series, they have selected our university and they have nominated the organizing chair as Professor Yagna Narayana sir, and I am coordinating with him as the co-chair, co-organizing chair in fact. So we have framed the committee inside the CARE to organize this conference successfully, because a person can think a lot. We have no restriction on our thinking level. We can think up to the sky. But to bring on a thinking into an action, we definitely need people. That time we definitely need to depend on the other people who are living in and around us. In that way, we have depended the Department of Mathematics and the Department of Computer Science, Department of Information Technology, Department of Computer Applications and Department of Computer Science and Information Technology, faculty members as well as scholars. We have framed many committees, we have given the responsibilities to them, and they have done all their responsibilities very well with a very good level of coordination. That is why we were able to successfully complete this ICMC conference. If the conference in charges and the faculty members related to a particular committee are here, kindly stand up whenever I am calling upon the particular committee. The publicity committee, headed by the committee chair, Dr. C. Balasubramanian, Associate Professor, CSE Department, and Dr. Suprakash, the most wanted person by Agna sir always. Dr. Suprakash. Ashok, okay. Yeah. The committee was in charge for website creation and content development, preparation of flyers, brochures, abstracts, souvenirs, printing and dispatching the same. The conference promotion, public relations, conference website, payment portal maintenance, and schedule preparation. Around 20 faculty members were involved in this work. Dr. Srinivasulu from Mathematics, Dr. Maharajan from CSE department, Dr. Sangala Mahalingam from CSE, Dr. Vijay from CSE, Dr. Arvindrajan from CSE, and Dr. Jane Rubal Angelina, Associate Professor from CSE. Many of the time, during the beginning times, Yagna sir used to pronounce only the name Jan like that. That much contribution she has given. Dr. Vimal Subramanian from CSE, Ms. Ahilandeshwari from CSE, Dr. Vivek Robinson from CSE, and Ms. Lavanya from CSE. Dr. Mureshwari from CSE, Ms. Aishwarya from CSE, Dr. Jeevida from CSIT, and then Dr. Amarendra Reddy from Mathematics, Jnanakumar from CSE, Mardu Bandi from CSE, Suresh Babu from CSE, Bharat Kesavan from CSIT, Dr. Muthuvel from CSE, Ms. Induja from CSE, Ms. Srilekha from CA. Again, Srilekha's contribution is noteworthy in the reception committee. During the inaugural time of the conference as well as the symposium, she has given a wonderful contribution. And she is very good in accommodating the participants also. Many of the participants have become almost friends to her, in fact. Jeevita, I'm having separate committee, yeah. And Ms. Kalerasi, Mrs. Durgamina, and Dr. Manikumar, and Dr. Karthik from Maths, and Ms. Esther from Maths. Yeah, the next committee. Publication committee, headed by Dr. N.C. Brinda, Associate Professor, CSE Department. Their responsibility include receiving and organizing the papers received, preparation of the Springer conference proceedings and the journal publication. We have the committee members, Ms. Esther from Maths, Karthik from Maths, and Sam Pradeep Raj from CSE, Satish Kumar from CSIT, Ilayaraja from CSIT, Anita from CSE, and Karthik from Maths, again Ilayaraja. Yes, this team, they have taken all the papers, they have splitted the papers into under different themes. They have selected the reviewers internally as well as external. They have received the comments from the reviewers. They have consolidated and they have given the consolidated comments to the organizing chair. So this committee's work is very much essential, in fact, for the successful organization of any conference. Thank you, Dr. Brinda and your team. And Finance Committee, headed by Dr. Karupasamy sir, Mathematics Department. Again, Karupasamy sir is almost like, another Yagna sir for us in organizing this conference. His role from the day one, it's very important. He has guided almost the entire faculty team in many of the work. Wherever some conflicts come, issues come, immediately I used to run to Karupasamy sir, what is this, how to handle this? So we used to discuss, and then he will talk to the faculty members, and then again bring all of us together. Dr. Maharajan from, C. Maharajan from Maths. Yes, and Dr. Dileepan Rajkumar from CSE. They are the co-committee in charges. Their work include registration, preparation of various kind of forms, managing the funds, and certificate preparation. Sir is assisted by many people, Dr. Vimala Devi from Maths and Dr. Mureshwari from Maths, Dr. Sivananda Saraswati from Maths, Dr. Ponmoli from CA, Dr. Sivamurugan from CSE, Dr. Baby Shalini, IT, Dr. Anushya, CSE, Dr. Vignesh Kumar, CSE, Mr. Ramkumar, IT, and Dr. Sivakumar, IT, and Mr. Shaktikant Durai, CSE, and Mr. Jafar Shadiq Ali, CSE Department. Thank you, sir. The next committee is the Catering Committee, headed by Mr. Vignesh from CSE Department. In fact, all of us should give a big round of applause to him. He took care of the coffee, tea, snacks arrangement as well as the lunch arrangement. The lunch was so delicious. Thank you, Vignesh, for being with the ICMC chair. Yeah. The team is assisted by Dr. Kameshwari Madam, HOD Maths, and Dr. Nagaraj, CSE. And their work obviously include hospitality for chief guest, arranging the lunch, breakfast and dinner, arranging the tea and snacks, volunteers refreshment, arranging the venues, and providing on time all these things. So it's assisted by Ms. Anita, Maths, Dr. Vel Murugadas, CSE, Dr. Rajkumar, Maths, Mr. Tangapandi Maths, Dr. Nagaraj CSE, and Mr. Mari Chelvan CSE, and the student support of CSE department as well as mathematics department. Thankful to the student volunteers also. The reception committee headed by Dr. Amuda Guga and Dr. T. Shanmugha Priya. There are two Shanmugha Priyas in mathematics department. Both of their contribution is again very much noteworthy. They have contributed very well.
Shanmugha Priya is there, but Dr. T. Shanmugha Priya could not come here due to, since she has met with a minor accident.
Oh.
So otherwise she would have made it.
Yes.
So,
she was very active for the entire conference duration. I was kept on telling to Yagna sir. Yes. Preparation of agenda, stage management, arranging a reception and registration desk, honorarium, memento and shawl to the chief guest, feedback form from VVIPs and VIPs, chief guest and speakers. These were the responsibilities allocated to them. Dr. Rajesh Shekhar CSE, Dr. Prem Raja IT, Ms. Indumati CSIT, Mr. Sundareshwaran CSE, Ms. Sangeeta CSE, Dr. Sridevi Maths, Chitra Maths. These are the people who assisted them. Dr. Parivalagan, Ms. Layola, Ms. Amuda, Ms. Reshni, Ms. Sujita, all are from CSE department. And of course, Mrs. Shanmugha Priya also, and Thangamuniappan from Maths, Mr. Dinesh Kumar from Maths. They have assisted this committee. Next, the most important, and I hope the guests also will join their hands, Transport and Accommodation Committee. It's headed by Dr. Pradeep Kandasamy, Computer Application, and Mr. Madheshwaran from Mathematics Department. Excellent job for the past 1 week. I think the amount of time Pradeep has slept every day, hardly it could be 3 hours or 4 hours, not even a continuous sleep of 1 hour. He always used to keep the mobile phone with him to get a call anytime from our guest actually. It's a, very, very hard working effort by Dr. Pradeep. Yes. So accommodation of chief guest and invited speakers, accommodation for participants, logistics and all kind of transports. He is assisted by Dr. Shankar Narayanan and Mr. Sundareshan and Ms. Kayalvili from Mathematics Department, and Dr. Bharat Singh, Dr. Surendra Muthukumar, Dr. Palani Selvam, and Dr. Venkatesh, Ms. Raghavardhini from CSE Department, and again Dr. Maharajan from Maths Department. And this team, they have assisted Dr. Pradeep in accommodation. Next is Facilities Committee, Dr. Baby Shalini from IT Department. Normally Facilities Committee, we used to keep any male faculty as the in charge. The very first time we have kept Dr. Shalini as the in charge. I should mention some 2-3 weeks before she lost her mother in fact. She took only 4 days leave and then she has come back again to the university and she continued her work. So we should appreciate her a lot. And she rightly understood the intention of Yagna sir in arranging the halls actually, and she used to come first and she used to leave last from the university. Such an excellent work by her. So the lecture hall identification and preparation, local tour arrangement, session chair committee, report preparation, panel discussion and recommendations, photography and video coverage. All these come under this facility committee. She is assisted by Dr. Muthukani from Maths and Ms. Tamilarasi and Ms. Sumitra from Maths. All others are from CSE. Dr. Anushya Devi from CSE. Mr. Vignesh Kumar from CSE. He has joined in the last moment, but he contributed very well for the past 2-3 weeks. Dr. Sivakumar from IT, Dr. Rajkumar from IT, Ms. Shanmugha Priya from CSE, and Mr. Shaktigan Durai from CSE and Jafar Shatik Ali from CSE, and Dr. Radhika and Dr. Sumitra from Mathematics. They all have contributed for this facilities. Next, disciplinary committee. Disciplinary committee mainly to bring the students to the venue and then making them to understand, sit in the sessions very effectively. I should thank the head of CSE department, IT department, CA, CSIT department very first. I should thank them because they organized the student members very well according to the keynote sessions we have planned. Some of them are, real mathematics session. Most of them are, of course, from the computer science sessions. So based on the title, they have rightly identified the students from the cyber security stream or from the AML stream. And then they have made the students to attend the keynote sessions. And I should mention about Dr. Abhishek Tripathi also in this time. He has brought the students very well for the symposium inauguration as well as for the conference inauguration. Coordinating the students nowadays, that even with a big crowd, it is the challenging job, but he has done it very smartly, in fact. So thank you, Dr. Abhishek Tripathi. The other members include Ms. Shanmu Priya from CSE and Ms. Bhavani, Ms. Benita and Ms. Kardeepa from CSE also. The committee's work included event coordination, forms and report writing, arranging the security guards, NCC, NSS arrangement, informing the security, and then identifying the faculty members, identifying the locations, and the other works related to the disciplinary committee. Thank you, Abhishek. The technical report writing, again headed by Dr. N.C. Brinda, assisted by Dr. Subbulakshmi from CSE, Bhavani from CSE, Ms. Sangeeta from CSE, Ms. Raghavardhini from CSE, Ms. Abhirami, the research scholar from CSE, and Ms. Jeba, research scholar from CSE. They have assisted Brinda Madam in preparing the technical report writing. And the session management, we have deputed the faculty for the same. Dr. Arifa Beham and Ms. Kritika from CSE, and Ms. Guru Sigamani and Ms. Layola from CSE, Ms. Syed Ali Fatima and Ms. Rashmi from CSE, and today for the session management, Ms. Sangeeta from CSE. So I should thank these faculty members for coordinating the sessions excellently. And the last committee we have framed to manage our finances is the stall committee. The stall committee was headed by Dr. Jeevita from CSIT. Again, stall committee we used to give to male faculty members, but this time we gave to the female faculty member, and she has coordinated excellently with the other faculty members and with the student members, and she has created many student entrepreneurs. Many of the stalls are actually organized or run by our own student members. Students were enjoying, faculty member were enjoying all the stalls. We tried for the first time from our side. Usually it is done by the Student Affairs Office. So we have done for the first time. Of course, we have almost succeeded in that. So thanks to Dr. Jeevita team for organizing the stalls in an excellent way. So almost I mentioned about every department. This is organized by two schools, in fact. One, another school, only Department of Mathematics. All the departments from School of Computing. So both the departments have gained a lot of experience. They came to know about each other. Because our vice president always used to tell one thing. In Tamil there is a proverb like Kalyanam Pannipar Veede Kattipar. That means conduct a marriage and construct your own house. You will know about all the kind of responsibilities, problems under the sky when you conduct a marriage or when you construct your own house. Similarly, a new phrase is adding into this. Organize a conference in an academic institute. You will get all the kind of experience under the sky, in fact. You will come to know. You will put a committee. That committee will not work. Some other committee will come and work. I mean, the people who are not allocated the work will come, sometime come and then work. So you will come to know about the people who will be coordinating with you, who will be talking with you, and I mean in front of you as well as behind you, who will be always working, but they won't come to the front. They will be always behind the scene. Almost you can identify the people whenever you are organizing a conference. Similarly, money management, everything you will experience like you organize a marriage or like you construct a house. So we all had a wonderful experience. The Kare Mathematics and SOC team, we had a wonderful experience along with Yagna sir in organizing the conference. It's really a wonderful experience, and our faculty team can easily organize a conference anytime in the near future. Thanks for the experience. Thank you.
Thank you, ma'am. I request dignity members to to give our participate certificate for one person, sir. Kundakarla Shyam from Kalasalingam University. Thank you, sir. Gratitude is the fairest blossom which spring from the soul. Every celebration is an experience, the external fade away.
So before we go into the conclusion and vote of thanks, I would like to make a small announcement that we have, Madam has already summarized the names of faculty members who served in various committees. So as a token of appreciation from the top management, we have purchased some mementos for them. So now as the time is running out so badly, we will make those mementos reach you in your place on Monday through the concerned school deans or HODs. Thank you very much. Everybody who have contributed, all members will be presented with a memento. It has already been purchased, but it will take about 100 members, so it will take another half an hour. So because of the time factor, it will be distributed to you in your seat on Monday by the respective school deans head of the departments. Thank you.
Yes.
Sorry, because I get emotional sometimes. I utter a few words that could not be really considered to be appropriate. Especially, I withdraw my words that yes, we have organized in a much better way. I should not have mentioned some other institution's name. So that was rightly pointed out to me by Dr. Dabasis Giri. So that is so I take back those words for mentioning the institute's name. Openly, I express my apologies. And then I forgot to invite Dr. Dabasis Giri, who is the program chair for this conference, and it is his privilege for the past 1 year from January 2022 when Dr. Punnusamy initially accepted and invited me to organize this series of conference. He said, I will introduce you to one main person of this conference who is the founder, Dr. Dabasis Giri. From that day onwards, we were talking, and there is no time for us. Morning 4 o'clock, 3 o'clock, night 12 o'clock, 11 o'clock, any time, 24 hours we were in conversation with each other, and all his valuable suggestions and guidance has helped us to organize this conference successfully, and we hope to interact in some other occasion in future. So I now give my stage to Dr. Dabasis Giri to share his experience with me and with all the members of this college.
So thank you, the Ignarayan, because you see, once Professor Punnusamy told me that if you are interested, if Kalasalingam interested, then you can give the conference to that organization or not. Then at that time I was hesitant whether I will give or not. But after that I discussed with the organizing chair later, and many days we have discussed. Then finally we have decided that okay, we can organize, we can help. So last 1 year, basically we do not know. I talked to the organizing chair, but they have shared the knowledge, their experience and what I have talked, they have shared to you people. So my thanks goes to the organizing chair and their teams. And you see, they have, I want to compare with other because this is the 10th of its series. I have organized this conference in my organizations, old organizations, Holden Stop Technology 3 times. After that, I organized this conference in different institutes. Next time, 2018, I have organized this conference at IIT Beiju. 2019, KIT, Kids Bhubaneswar. Then IST Shibpur. Then we have organized one in the hill area that I forgot the name. Anyway, this is the 10th, Sikkim. Okay. So this is the 10th of its series. Now we see next year we will organize the 11th of its series. We have got just some request from different institute, even outside India also. So it is not decided yet. Hopefully we see within few days we will decide and we can share the information and hope that we expect that you should participate in the next conference. And you see, one thing I want to mention that they are organizing that organizing chair. They have structurally organizing this conference. Structurally, even I have organized 3 times. I was not that much structured. Whatever when I asked him, immediately I got the answer. But I am having experience. Still, I am telling that structure way I have not organized. Even you see that 3 times, and I personally organized, and 6 times, excluding you, they have organized, but I have not seen that structure. Okay. So I want to back up because I don't know, because other organizations they have organized in better way also. But you see, structured way nobody has organized like this one. So my hearty gratitude goes to the organizing chair and that university also. And we also thanks to the funding agencies, the DRDO and NBHM and your university. Thanks. Hopefully we will meet again in near future. Thank you.
Gratitude is the fairest blossom which spring from the soul. Every celebration is an experience. The external fade away and the internal rings and echoes in the most depth of our hearts. We are reminded in that events like this 1 hour milestone on the journey of life and reminders on God's fidelity all true. As we come to the close to our valedictory ceremony, I invite Dr. M. Kameshwari ma'am, head of the mathematics department, to propose the vote of thanks.
Dignitaries on and off the dais, my dear fellow faculty members, research scholars and student friends, good afternoon to all. It gives me an immense pleasure to propose vote of thanks in this remarkable and unforgettable event. First and foremost, I humbly bow my head with gratitude to the God Almighty and to our founder chairman for showering abundant blessings for the successful completion of the 2-day symposium and 4 days international conference ICMC 2024 in our premise. My sincere thanks to the management, Vice Chancellor, Registrar, for being readily available to encourage, guide, direct, and support in all our endeavors. My wholehearted thanks to the general chairs, program chairs, organizing chairs, Debasis Giri sir, Professor Ponnuswamy, Professor Egnan Narayanan sir, Professor Karupasamy sir, Professor Deeplakshmi ma'am for selected our care and conducted such an extraordinary and unforgettable conference in our premise. My respectful gratitude to all the members of Galaxy of Resource Persons from the Institute of National and International Repute across the globe and provided with feast of knowledge to all of us. My handshaking thanks to each and every participants from various parts of the world decorated this conference with enthusiastic participation and presentation. You are the main ingredients of this delicious academic feast. Thanks to all of you once again. My special thanks to all the heads and organizing members of CARE and faculty members of School of Computing, Department of Mathematics for their tireless support and dedicated service for the smooth conduct of this conference. My lovable thanks also to the student volunteers and research scholars of SOC and Department of Mathematics for rendering their subjective support. I would also like to extend my gratitude to all the technicians, non-technicians, members of press, media, transport, guest house, hostel, NSS and NCC students, and also to all the people who have involved directly and indirectly for the smooth and abundant success of this 10th edition of ICMC along with symposium. Not but not the least, to all the funding agencies who supported with abundant finance for this great conference. On behalf of the management, Vice Chancellor, Registrar, organizing team, and also on my own behalf, once again, a big thanks to each and everyone. Jai Hind.
Thank you, ma'am. The end of the story is a new beginning for many others. On this note, let's conclude a remarkable, memorable, and knowledgeable valedictory session. On behalf of the Institute, we sincerely thank dignitary members with their support, enthusiastic, and heart-supported rendered in the success of this valedictory session. Thank you, sir. Now I request all members to stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे